Hey guys, sorry that I can't be there today, but I hope that today is actually going to be pretty easy even without me there. Be aware though that you will need a calculator for what we're doing today, um, and I'm going to try to make this as quick as I can so that I can go to bed and you guys can move on with other stuff. Um, so today we're going to kind of be moving into like the big thing for this chapter. Like I said, this is a pretty short chapter. There's only one more lesson after this. It's going to be all word problems. But today is kind of like the skills that you need in order to be able to solve the word problems. So let's go ahead and get to it. Let me refocus this real quick. All right. So inverse matrices are the first thing we're going to look at because we're going to be solving systems of equations today using inverse matrices. So first I need to tell you a little bit about inverse matrices and what the heck they are. Before we do that though, I want to look at this equation, the 6x equals 12, and we can solve it in two ways. And I know that you know the obvious way is just take both sides and divide by 6, and you get x equals 2, and it's easy. That's fine. So we've looked at how to add, subtract, and multiply matrices. That's what we did on Thursday. But there's one other way that we could get this x by itself, and that is instead of dividing by 6, we could multiply by 1 over 6. Because 1 over 6 times 6, they cancel each other out. In fact, they have a very special name, 1/6 and 6 do. These two numbers are what are called multiplicative, which is a favorite math word of mine to say, inverses. And all that means is that they're reciprocals of each other, and multiplicative inverses always multiply to get 1. So that's a way that we can sort of cancel out that 6, is multiplied by its multiplicative inverse, and then 12 times 1/6 is still 2. So we get the same answer either way, but this is the way that we're going to sort of clue in on today because, like I said, we've learned how to add, subtract, and multiply matrices, but matrix division isn't a thing. So we can't divide matrices. Somebody in one of the classes asked me that on Thursday, and we're not going to divide matrices, but inverse matrices help us, quote unquote, divide matrices. So we can't actually do matrix division, but we can, like, sort of here, we didn't do any division, but we still canceled that 6 out of there. So that's sort of what inverse matrices are going to help us do. It's going to help us divide without using division. So a little bit of terminology about them. The inverse of matrix A is called this. All right, so it's written as, whatever matrix you have. It's just that, and it has like an exponent of -1, but we read this as A inverse. So I know, not very creative, that the inverse of matrix A is called A inverse, but that's how we write it. A to the -1 is the inverse of matrix A. So you're not really going to have to do a whole lot of inverse matrices by hand, really, ever. We're going to use the calculator for this a lot today, and also tomorrow. But for matrix A, that looks like this, it just has 4 numbers in there, A, B, C, D, its inverse is a pain in the butt to find, because A inverse is found by taking 1 over, are you ready for this? AD minus BC, and then you take that fraction and you multiply it. You do scalar multiplication by the same numbers in here. You take these A, B, C, D numbers and you kind of jumble them all around, and you take D, negative B, so whatever B is, you take the opposite, negative C, A. That's how you find the inverse of a 2 by 2 matrix. It is not fun. There's like a whole class on this in college, and I did not have fun in that class whatsoever. But like I said, you won't really need to worry about that too much. The calculator is going to do that work for you, but that is how the calculator does find it. The important thing about this inverse is that if you multiply A times A inverse. Actually, hold on. Backtrack, because I already messed that up. Remember that with matrices, multiplication is important. If you multiply A inverse times A, so if you take the inverse on the left and the regular matrix on the right, its result will always be the matrix 1, 0, 0, 1. So it'll still be a 2 by 2 for these 2 by 2s, which is the matrix equivalent of 1. And I say that it's the matrix equivalent of 1 because you can multiply by this matrix, like as long as the dimensions work out, you can multiply by this 1, 0, 0, 1 matrix, and it will never actually change the matrix that it is multiplying. So it's kind of like 1. You can multiply any number by 1, and it will never change the number that you multiplied. So this matrix, that 1, 0, 0, 1, it's called the identity matrix. So, and in the case of like a 3 by 3 instead, it would just be 1, 0, 0, 0, 1, 0, 0, 0, 1. But anyway, you don't really need to know that, but yeah. So basically, we don't do matrix division. We multiply by an inverse matrix, and it's the same as dividing by a matrix instead. So we're going to need that because we're going to have to sort of solve equations with matrices in them today. And we're going to need to multiply by the inverse in order to solve them. So, okay, moving on to the next part. Systems of equations and matrix equations. So what we're going to be using matrices for is solving systems of equations. Back in Module 4, when we had like all the crazy graphs that we were doing, we graphed systems of inequalities in order to solve them. So like that was where we shaded, we found corner points, we built a table, right? And then we did those word problems that took like 13 hours in order to do each problem. So matrices, though, can be used to solve systems of equations. So rather than having like the greater than, the less than, these are all just going to be equal to. So a system of equations consists of at least 2 equations, or I should say 2 or more equations. And can just look like, I don't know, I'm just going to make up random equations here. So if we did a little, 2 equation system of equations, we could have like 2x minus 5y equals 3, and like negative x plus y equals 11. That is a system of equations. So just like we had systems of inequalities, the only difference is these are just equal to, so no shading. The solution to a system of equations is the point at which all the equations intersect. So this system only has 2 equations. They're going to intersect at a point as long as they're not parallel lines or coinciding lines, but they should intersect at just one nice point. We are also going to write systems that have 3 equations in them, so all 3 of those equations would have to intersect at the exact same point. And that is the point that we are trying to find. So here's what I want to do. So in order to kind of see how this goes, we are going to multiply these matrices. All right, just like we did last week, like you guys did for me on Thursday, and then again on Friday. So I want to multiply them. So first of all, let's check and make sure that we can actually multiply them. This is a 2 by 2. This is a 2 by 1. Inside dimensions match. And our result should be a 2 by 1. So we should get a 2-row, 1-column matrix out of this. So I'll go ahead and label everything. So we should have 1 column, first row, second row. So I'll label my rows, row 1, row 2. I'll label my column, column 1. And then I'll go through and do my multiplication. So to figure out what goes here, that's in row 1, column 1. So that means I need to take First number in the row times the first number in the column, that's 2x, plus second number in the row by second number in the column, 3y. All right, that's not so bad. Then to figure out what goes in row 2, column 1, I take row 2 and I multiply it by the column. So first times first, that's negative 1x, plus second times second, that's 4y. So notice that we can't really simplify that at all because you can't combine x's and y's together. But the thing that I want you to notice is that this kind of looks like a system of equations, right? Like this kind of looks like if we took our 2x plus 3y and our negative 1x, or just negative x plus 4y, it's more or less a system of equations. It's just like equals, I don't know, equals 4 equals negative 9. But this is basically a system of equations. So if you take a matrix that has a bunch of numbers in it, a 2 by 2 with a bunch of numbers in it, and multiply it by this 2 by 1 with your variables in it, when you multiply them together, you kind of sort of get a system of equations. And that's what we're going to be using it for. This is without a doubt the most important thing to take away from today, is how to go from a system to a matrix, and a matrix to a system. So what we have is this system of equations. This thing that we have right here is going to be called a matrix equation, or these things down here are going to be called matrix equations. So the big thing from today is being able to take a system of equations and write it as a matrix equation. Alright, so what the heck do I mean? I mean exactly what we're going to look at right here. So this is a matrix equation. And what we want to do is write them as a system of equations. And I'll specify in here, do not solve, because I haven't shown you how to solve this yet. That'll be what we do at the end. So this is our matrix equation. So I'm going to take this, and I want to write it as a system of equations. So here's the thing. If you go through and just multiply this side out, you'll get sort of what we did up here. But look at the way things are organized up here. We got 2x plus 3y and negative x plus 4y. Take a look at where that came from. That first row was 2, 3. That column was x, y. So we got 2x plus 3y. So let's translate that down here. If we take our row, that first row, and multiply it by that column, what do we get? Well, we get 3x and negative 4y, so 3x minus 4y. If you do the same thing with the second row and that column, you get negative 5x and 2y, so negative 5x plus 2y. So the thing is, where the heck do those come into play? It's exactly what you may think. That first one, that top row in that one, is what that first equation equals. That bottom row is what the second equation equals. So this is our system of equations, right? Negative 3x minus 4y equals 1. Negative 5x plus 2y equals 3. This is our system of equations. All right, and that's why you need to know how to multiply the matrices together so that we could see how you can go from a matrix equation to a system and vice versa. All right, so I want you to take a second, try that second one, pause the video, do it without me, all right? And then once you think you have the answer, listen to it and make sure that you got it right. So pause it, try part B. All right, hopefully you paused it before you're watching this part. So if we want to take this matrix equation, write it as a system, my first row in my first matrix is my first equation, so that gives me negative 5x minus 5y equals 25. And then my second row gives me my second equation. Negative 2x minus 4y equals 16. There we go. That's our system. That's not so hard, right? That should take like all of 10 seconds. So there you go. Even if I added in a third row on here and a third variable in here, it'd still work out the same way. We're going to see some of those on the back because you're going to see a lot of those in the word problem. So get used to these things looking bigger and uglier. All right. Hopefully that's not so bad so far. All right, let me go to my other copy. All right. So now, here, before we start solving some systems, I want to go the opposite way now. It's important that you cannot necessarily just go from a matrix equation to a system, but make sure that you can go from a system of equations into a matrix equation. So, that's what I want to do. Here I give you a system. I want to write this as a matrix. So, you're just going to have to go backwards from all the stuff that we just did. So remember, try to do this one without me. All right, see if you can go backwards with it. If not, then listen to my help. But those coefficients, those numbers there, remember that's just your first matrix, that in this case 2 by 2 because you have two equations and two variables. So that means that your first matrix is just going to have 4, negative 3 in the top row. Here we just have an x. So that means we're going to have a 1, right, because there's really one x there, and 5. Then that is going to multiply your variable matrix, xy, and that's going to equal sort of your answer matrix, 17, 21. That's really all there is to it. And that's going to be the thing that we do a lot more of throughout this lesson and the following lesson, the one that we're going to be doing tomorrow when I come back. So, there you go. Pretty easy, right? All right, let's start throwing in the calculator steps to them. So if that one wasn't quite clear, then don't worry, we're going to see it 4 more times on here. So I want to write each system of equations as a matrix equation and solve. So that's going to be our new step, solving. And then I want to show all work required to find the answer. I promise that work is not a whole lot because the calculator does most of it, and it's the same work every single time. So, all right. So here's what we're going to do. We're going to take this equation, this system of equations, and we're going to write it in matrix form. So let's write it as a matrix equation. So that's our first step. So write as a matrix equation. So my first matrix, I have 2 variables and I have 2 equations. That means I'm going to have a 2 by 2. And that's going to be 3, negative 4, negative 2, 3 times my variables, x, y, equals my answers, 3, negative 1. All right, there we go. Do you like how my matrices get slightly taller as I go along? Anyway, all right, so here's what I'm going to do. I'm going to label these matrices. I'm going to label them. My first matrix, that 2 by 2, I'll call that one matrix A. That one with my variables, I'll just call matrix X. And then this other one over here, I'll call that matrix B. So really what I have here is I have, and this is the work that I'm talking about, my work is that right now my equation is that matrix A times matrix X equals matrix B, right? What we want to do is if we want to solve the system of equations, that means we're going to be solving for the numbers x and y that make these two lines intersect. We want to find the point x, y at which these two lines cross each other. So what we want to figure out is we want to basically solve for this x. Right now, this x is being multiplied by matrix A. But, as I kind of talked about at the very, very beginning, we can't divide matrices. So what we do in order to sort of divide, quote unquote, by matrix A is we are going to have to multiply both sides by A inverse, right? That's how we cancel out the A, by multiplying by its inverse in order to solve for that x. But here's the weird part about the matrices. Remember that the order matters, which order you multiply in. So what I want to do is I want to multiply by A inverse on the left. So not just on the left side of your equation, but on the left side of both sides of the equation. Here's what I mean. I'm going to take A inverse and multiply that. Notice that it came first, it went on the left, times A times x equals, but now on this other side of the equation, I'm going to multiply by A inverse. It's important that it goes on the left side of the B of that matrix that I'm multiplying it by. So what happens is this A inverse and this A cancel each other out. So this is sort of the work that's required. What we get is that matrix X is equal to the inverse of A times matrix B. All right, and this, honestly, is the key to solving these problems, knowing that the answer that we want is found by taking the inverse of matrix A and multiplying it by matrix B. So here's what we're going to do. We're going to switch over to our calculator, and I'm going to show you how to do this in the calculator. So do this in the calculator. All right. Doesn't matter if you have a TI-83 or a TI-84, it kind of works the same way in both. So here's my calculator. So what we're going to do is we're going to have to type in matrix A and matrix B. If you notice right here on the calculator, right above this little x to the -1 button, it says matrix, and it's blue, so we're going to go second matrix. We're going to need to go over here to edit. So let's go over to edit, and we're going to put matrices in for A and B. Now you might have like dimensions sticking out over here, like it might say 3 by 3, it might say 2 by 2, whatever, it doesn't matter, it's fine. I just don't have any matrices in here. So, by the way, I recommend writing down these steps. We did second, X inverse, I went left to the edit button, or the edit column. So the first thing I'm going to put in is I'm going to put in matrix A. So I'll press enter. So up here, it's asking for the dimensions of matrix A. Now, my matrix A, as you can see, is a 2 by 2, right? So we need to tell it it's a 2 by 2. So I'm just going to type in 2, enter, 2, enter. And then now it's set up a 2 by 2, it puts zeros in. So now go ahead and put in all of your numbers. So we have 3, and every time that you type in a number, just press enter, it'll jump across the row. So it's 3, -4, whoops. What are you doing? 3, oh, duh. -4. And then we have -2, enter, whoops, nope, not -22, come on, found. -2 and 3. Alright, so matrix A is done. Very, very important thing that you do now. Once you get everything typed into matrix A, it's very important that you quit. So second, quit right now. Go back to that home screen. Now go back to the matrix menu, second matrix, go back to edit. This time we want to go down to matrix B. Let's go down to number 2, enter the dimensions of matrix B. Remember, we're not typing in our XY matrix. We're not doing matrix X. Matrix B, though, is a 2 by 1, and all it had was 3, -1. Now I'm going to quit out of it again. All right, going back to my notes here. Remember that this is what we want. In order to find that matrix X, the solution, we want to take A inverse and multiply it by B. So I'm going to go back to my calculator. I'm going to go back to the matrix menu. I don't want to edit now. I just want to take matrix A. So in that first column, the names column, I want to take matrix A, but I want its inverse. The inverse button is just that button that we've been clicking this whole time in order to get the matrix. So we're going to do A inverse times, just multiply by, and then go back to the matrix menu, second matrix. I want matrix B, and there we go. So our answer matrix, that X matrix, is the 2 by 1 that contains 5, 3. So this means that X, big X, is equal to the matrix 5, 3. But be very careful how you write your answer. This 5, remember, is your X. That means that little x is 5. And this 3 represents your Y. So what this means is that these two lines intersect at the point 5, 3. That is the answer that we are looking for. The solution to this system is 5, 3. That is the point where they intersect. I know there are much easier ways to solve this system of equations, but this is going to be the important way because do you see these guys down here? These guys get pretty nasty. So, all right, that one hopefully wasn't too bad. So let's try this again. All right, if you think you've got the steps down, then by all means, please do this one on your own. All right, write it as a matrix, put it in your calculator, and then try to get your solution. So try to do it without me if you feel comfortable. If not, I'm going to roll through it. All right, step 1, matrix equation. So I'm going to take this. I have 1x, negative 3y, negative 3x, 6y. I'm going to multiply that by my xy, and that's going to equal the matrix 5, 8. All right, I'm going to ask that you label your matrices. A, X, and B. Don't get fancy, just label them the same way every time. The work that I want you to show for me is just tell me that you know that matrix X is equal to A inverse times B. All right, that is what the work is that I need to see. So show this. Please. That's all the work I'm asking you to show. All right. So now, basically, anything that I write down on this problem, I want you to have written down when you guys do your homework, when you guys do your tests, when you guys do your quizzes. So, go ahead, put A and B into your calculator. So just go back to the matrix menu, go back to edit. You don't need to put in the dimensions again. A is still a 2 by 2, so it's going to be 1. It's going to be negative 3. It's going to be negative 3 again. And 6. Remember to quit, second quit, go back to matrix, back to edit, down to B, still a 2 by 1, we've got 5, 8. Alright, I'm going to quit again, and this is where we type in this stuff, A inverse times B. So bring up your matrix, A, tell it to do the inverse, times, go back to matrix, B, there we go. Alright, so this is a bit of an ugly answer. That's okay. Sometimes you do get fractions. Give me 1 sec to flip my page here. So this is totally fine. You get some ugly decimals. So by the way, your calculator, it will convert that into fractions. If you go to math, fraction, enter, it'll convert it into fractions for you. I think fractions look a little bit nicer. So show me that work. So negative 18 and negative 23 over 3. Matrix X is equal to the matrix negative 18, negative 23 over 3, which means that remember that top one is our little x, the bottom one is our little y, so our lines intersect at the point negative 18, negative 23 over 3. There we go. All right. Easy enough. See, not that hard. All right, we've got 2 more to go. These look a lot worse, but I promise they're really not. All right, if you can do the other ones, you can do these. So, step 1 is still to write them as a matrix equation, but be very, very, very careful. All right, notice that here we have 3 equations and 3 variables. That means that now A is going to be a 3 by 3. We have 1x, negative 1y, 1z. Notice in this one, we have, I'm going to write this over here, we have no x's, 2 y's, and a negative z. So that means you must say 0x. So think about this as like your x column, your y column, your z column. All right, so always keep your x's, your y's, your z's lined up. That's very, very, very important. So 0, 2, negative 1. In this one, we have 2 x's, 3 y's, but we're missing our z's. So 2, 3, 0. Now, we're going to multiply that. So now, since we have x's, y's, and z's, we need to reflect that. X, Y, Z. So now we have a 3 by 3 and a 3 by 1. Still legal, you can still multiply them. And it's still going to equal a 3 by 1, negative 5, 2, negative 3. All right. I'm going to go ahead and name these things. That's still A, that's still X, that's still B. So we can go into our calculator and type them all in. So go back to matrix, matrix, go back to edit. Now though we need a 3 by 3. So we have 1, negative 1, 1, 0, 2, negative 1, and then 2, 2, 3, 0. All right, there's matrix A, quit, back to matrix, back to edit, down to B. This is a 3 by 1, so negative 5, 2, negative 3. All right, I'm going to show my work. Ready for this? X is equal to A inverse times B. So this means that matrix X is equal to, quit out of this, we're going to go back to A inverse times, back to matrix B. And press enter. Ta-da! There we go. So this means we've got negative 6, negative 6, 3, 4. So that is our big matrix X, negative 6, 3, 4. So in this case, negative 6 is our X, 3 is our Y, and 4 is our Z, which means, I know it's kind of weird to think about this, but we actually do still write it as an ordered, it's not a pair anymore, it's an ordered triple. But negative 6, 3, 4. You can write it like that, or if you want, I'm also happy with it if you write X equals negative 6, Y equals 3, Z equals 4. Just take it out of the matrix and put it out like that. All right, and there we go. That's all there is to it. All right, good deal. There is one more problem. I want you to try that one completely without me. Do it on your own before you watch me do it or check my answer to it. All right, so take a minute, try it faultlessly. All right. Okay, hopefully you've done your video or done your problem without watching the video. So I'm going to set up my 3 by 3. Again, I hope you were careful. You have 2 x's. Remember, this is like your x, your y, your z. You have 2 x's, no y's, 3 z's, 1 x, negative 2y, 1 z, negative 1 x, 3 y's, no z's. Multiplying that by, this doesn't change, x, y, z, and that equals 5, negative 4, 2. I'm going to label them A, X, and B. And then I know that my work is that X is equal to A inverse times B. Ta-da! All right, go into my calculator. Second matrix, edit. It's a 3 by 3, so we need 2, 0, 3. I just realized as I was typing this in, I don't know why I wrote negative 2y. It should just be negative 2. My bad. So we should have 1, negative 2, 1, and then negative 1, 3, 0. Then we're going to quit. We're going to go back to edit, down to B, 3 by 1, 5, negative 4, and 2. We can quit. All right. Also, I know I haven't shown this part to you yet, but you know, rather than going in and typing A inverse B every time, shortcut, go back up and highlight it, press enter, it'll use the new A and the new B and find your new answer. So there's a new answer, 13, 5, negative 7. So that is our matrix big X. So 13, 5, negative 7, which means we have an ordered triple, 13, comma 5, comma negative 7, or you can write that X equals 13, Y equals 5, Z equals negative 7. All right, there we go. Whew. Cool. So hopefully that wasn't too difficult to do without me. I think, you know, you guys can probably handle that on your own. Tomorrow when I come back, we will check both this assignment that you're about to do for me and the assignment you should have done for me on Friday. So we will check both of those, and we will do word problems with these things. And then hopefully our test will be Thursday, no later than Friday. All right, that's the plan. This stuff, obviously, the stuff that we just did right here would be on the calculator portion. However, even the stuff that we did before where you just had to rewrite it might be on the non-calculator page. Might be on the calculator page, might be non-calculator page. I could go either way with that. So just remember that you will have a non-calculator section to your test this week. So, all right, that's it for now. I'm going to go to bed. I will see you all tomorrow. Bouts out.